the inverse function, many people get very little marks on functions, and personally I do not understand why, because the inverse function is very straightforward. People just make a misconception because they think it's hard, they believe it's hard, and then it becomes hard. Functions as a whole is simply grade 11. So we're just repeating it in grade 12. Everything in functions is just a repetition. So please do not fall into the misconception of saying that functions and inverse is hard. It's too simple, it's not hard. Now let's detail the inverse. What happens on an inverse function? So there are types of a function. There are types of a function. So the type of a function can be one-to-one function. So what is a one-to-one function? A one-to-one function is a function that has one y value for one x value. So one y value for one x value. That is a one-to-one function. And then from there we can have another function which is a many-to-one function. The example of a many-to-one function is the parabola. So which one between the x and the y can be many? The y value is constant. Well, let's say this is a parabola. The y value, let's say it's 6. It's constant. It's constantly y, but then we can have negative 2 here and 2 here. That means we have 2 x values for one y value. That is a many-to-one function. 2 x values more than, let's say, many x values for one y value. So if you think of a many-to-one, people usually mix these two. They say many y values instead of many x values. If you forget which one it is, just remember the parabola and check which one is constant. The y value is constant, but then we can have a lot of x values. And then from there we can have tests. From these two, one-to-one and many-to-one, we can have tests. If we can test if this thing is a function or if it's a one-to-one or a many-to-one. So the test is 2 of them. There's a vertical line test, and we have a horizontal line test, horizontal line test. So how do we test this one? I like to use the parabola to explain this because it explains everything in one time. So the vertical line test tests if this thing is a function or it's not a function. And then the horizontal line test tests if it's which type. The horizontal line tests a type, the vertical line tests if it's a function. So if the vertical line is like that, standing upright, it touches the graph once. So this graph is a function. If the vertical line test touches the graph twice, then that thing is not a function. An example of that is a parabola of this nature. This is an inverse of the parabola. We'll get to that and explain that. For now, just understand the vertical line test. So in this case, it touches twice. So that thing is not a function. When it touches twice, it's not a function. And we have to restrict. One part for it to be a function. When you restrict, it's either you are taking the upper part or you are taking the part below. And we'll explain the restriction once again when we get to the inverse of a parabola. So the horizontal line test, you come and draw your dotted line horizontally. How many times does it touch? It touches 1 and 2. then this function is which type? Many to one. If it touches twice or more than twice, it's a many to one. If it touches once, it's a one-to-one function. As simple as that. Now let's do the inverse in detail. So the inverse function, what you have to do, let's say we have a function f of x is equal to 2x plus 2. 2x plus 2 for an example. So we denote the inverse as f of x index negative 1. That is an inverse function. That is how you denote your inverse. So how do you get the inverse between the two? You swap the value of x and y, and then you solve for y. So this function is y is equals to 2x plus 2. Then from these two functions, from this function, we can sub these values. We're creating an inverse right now. Instead of y, I write x. Instead of x, I write y. Then make y subject of the formula, because a function cannot start by x. So we need to make y subject of the formula. That's going to be x minus 2. This 2 comes to the left, becomes negative. It's equals to 2y, and then therefore y is equals to x minus 2 divided by 2. So here we just divide both sides by 2, or take this 2, because it's multiplying on the right, it will divide on the left. This is our inverse. This is the inverse function of this original function. Then we can draw by table method. Substitute 1, 2, 3, 4, get coordinates, and draw your inverse function, as simple as that. And then we can use this notation. We can come here and say f of x index negative 1 is equals to x minus 2 over 2 to denote the inverse function of this function. And then now let's go to them in pieces, one type of a function to the other. So the straight line, this is a straight line graph. Let's say we have a straight line graph. It's passing at negative 2 and 0 and 2 and 0. So I have coordinates here, negative 2 and 0, and then 0 and 2. Those are my coordinates. So to get the inverse of this function, I simply swap the x value and x and y of the coordinate. So if we swap negative 2 and 0, we're going to get 0 and negative 2. That's how we swap. Just swap x and y. So the other coordinate, 0 and 2, if we swap this, we get 2 and 0. And then these are my new coordinates. This is the inverse. This is my inverse coordinate. I swap x and y. Then I can come and plot the graph here. So negative 0 and negative 2 will be right here. On negative 2, 2 and 0 will be right here. And that is my straight line. I connect the dots. So this is a reflection along the line y is equals to x. It's a mirror reflection. This line was reflected through y is equals to x, and it gave us this line. As simple as that. Now let's do another one. No need to erase this one. So the hyperbola is very interesting for one reason. It has an inverse already. That's an inverse. This piece is an inverse of this one. This one is an inverse of this one. It's a reflection of the other along the axis of symmetry. So we've been doing inverse without knowing. We did the hyperbola in grade 10, in grade 11, but we did not know that this is an inverse of this one. Now we know that's an inverse. It's a reflection of the line along the x-axis. the line y is equals to x. And then the positive hyperbola is like that, the first and the fourth quadrant, and also it's a reflection along the negative axis of symmetry. So this is an inverse of that one. That's your hyperbola. So hyperbola is not going to have an inverse because already it has an inverse of its own. So you will not be asked to draw an inverse of a hyperbola. How are you going to do it? Because it's already having its own inverse. So the exponential function can have an inverse. Let's say this is an exponential function. We know this coordinate, -2, positive 2, and we need another coordinate, one more. Let's say this is 3, x3, y3. No, let's use a different one for when we swap. So how do I get this one? So this one is 2, 0 and 2. This is 0 and 2. So I have coordinates 0 and 2. I have to swap the coordinates. So 0 and 2 will come here. It will be 2 and 0. 2 and 0. 3 and 4, it will be 4 and 3. So 4 will be x. 3, 4 and 3. Let's say 2, 4 will be here. 3, probably somewhere there. So my coordinate will be probably somewhere there. 4 and 3. Then I come here and connect my pieces with a shape of the exponential. And that is a reflection of the exponential along the line x is equals to y. As simple as that. Now let's do the difficult one, but it's very simple, the hyperbola. It's difficult because we need to restrict one part, but then once you understand that, it's very simple. So the hyperbola, the parabola I mean to say, the original parabola is like that. That is our original parabola. So the original parabola can have an inverse, and it's a reflection along the line y is equals to x. This is our line y is equals to x. So what happens when we reflect this graph? It becomes in this man. That's our reflection. It's in that man. And then if we go back to the test now and we put a vertical line test, we have a problem. It's touching twice. So it's not a function. Then we need to restrict the domain so that it can become a function. So for it to be a function, I need to either take the top part, or either take the bottom part. Then that restriction is from where? Turning point to the left, turning point to the right. So you simply restrict from the original. So this was the original. So to restrict, I come to the turning point and go to the left. So I took one part from the turning point. Or I come to the turning point and go to the right. What is that? Let's say this is an original parabola. Original parabola has a turning point at x is equals to 0 and y is equals to 0. So we are going to say that to the right, x is greater than or equals to 0. X is less than or equals to 0. That is our restriction. X is less than or equals to the value, the x value of turning point. X is greater than or equals to the x value of turning point. Let's say the turning point was, TP was -3 and 5. So then how do I restrict this one? X is less than or equals to -3, or x is greater than or equals to -3. As simple as that. This restriction creates this form. It takes one piece, and then that piece now, if I put my vertical line test, it touches once, then it's a function. So that is the restriction of the inverse of the parabola. And then one last thing, when we make an inverse of logarithm of exponential, I mean to say, this is an exponential function without the value of a, p, and q, to make it simple. So you can see that if we swap x and y, we have a problem now. When we have to make the subject formula y, we have to use logarithms. So the inverse of exponential is called a logarithm function. It's a logarithm function. So the logarithm function is on your calculator. On your calculator, there's a logarithm. It's written log, and there's two boxes. It's like this. There's a box and there's a box. That's your log. So then how do you make subject of the formula from here? You come y, the exponent, is equals to log base x, as simple as that. Y is the exponent, b is the base, and x is the value which was behind the equation, and that is your logarithm function. So when we swap the value of x and y on exponential function, we use logarithm to find the function of an inverse. And that is all about inverse functions. So inverse, just remember, swap x and y, that is your inverse. Swap x and y, make y the inverse, the subject of the formula, and then you have your inverse function. And then if you are drawing, swap the coordinates. If it's 2 and 0, make it 0 and 2. Dot dot, connect the coordinates. That's your inverse function. So you can agree with me now that we're doing the same thing, just standing the other way. So we're upright and downwards, as simple as that. And do not forget to restrict the parabola. If you make an inverse of the parabola and you do not restrict, it will be wrong. So you must make and restrict from the turning point to the left, turning point to the right. X is greater than or less than, or x is greater than or equals to the x value of the turning point, and that is inverse functions. And we end here. Let's meet again in another topic, and please remember to like, subscribe, and hit that notification bell so that you get more videos like this one.